Hi, welcome back to question number 18. Today we are going to attempt this question, car fleet. So this question is about n cars going down one lane road. We have a destination that is target miles away, and given two integer arrays, we have position and speed, both of which length are n, where the element in position I is the position of the ith car. Okay, yeah, and speed I, so in total the n cars, right, 0 to n minus 1, and then ith car and speed I is a speed, so each car has a position and each car has a speed. So we're looking at this, and then a car can never pass another car ahead of it, but it can catch up and drive bumper to bumper at the same speed. So the faster car will slow down to match the slowest car's speed. Okay, the distance between these two cars is ignored, assumed to have the same position. Okay, so there's no overtaking, and the car fleet is the same as some non-empty set of cars driving in the same position and same speed. So they will slow down to match the slower car speed, and they form a car fleet. Yep, if the car catches car fleet right at the destination point, at the destination point, it will still be considered a car fleet. Okay, so this is the question. Target is 12, so let's just take this as an example to make sure we fully understood the question. So in here we have position and speed as two arrays, and then since we have these two, we'll look at the entire array and look at how everything happens, right? So this thing, the target is 12. So position is 10. This one would actually meet, so let's just play everything forward, right? The position, how this works is that position 1 initially, and then everything would increase by 2, so this becomes 12, 8 becomes plus 4 becomes 12, this one increased by 1, this one increased by 6, this one increased to 6, because we just addition, and so you can think of this as position plus speed equals to 1 times speed, right? And here you can see clearly that because of this, we have two cars at the same position, and since they are still below or equals to the target, this will be considered one fleet, right? So here, fleet, right, we want to return num fleets, so let's just say num fleet plus equals to 1, right? And then yeah, for now this num fleet is 1, and then similarly we want to do this again, right? 2 times speed, and then we want to increment 12 to 4, 113. Let's just increment 113 here. We have 2, 7, and 9, right? Nothing happens here, nothing much. We do the process again. 3 times speed, right? Increment by 113, 3, 8, and 12, right? So nothing really happens, right? The starting car at 0 does not catch up to any car. So this does not catch up to any car. Yeah, we can see that this will just increment by 1, so nothing happens. This also increments by 1, so nothing happens, right? 5 speed 1, but this one on the other hand, right, we have 7 and 9, and this is the car starting at speed 1, starting at 5, and starting at 3. It's saying that these two cars become a fleet. Why is that so, right? We have 2 times speed, we have 1 times plus 1 plus 1, 5 plus 1, 3 plus 1. Sorry, I missed this. So this one, these two become a fleet, right? So this one becomes 2, and then here this one just becomes like that, and then this one just increases. 6 and 6 increases based on the speed of the slower one, which is 7, right? So this just becomes 7 and 7, yeah, and then 8 and 8, and so on and so forth until it becomes eventually 12, 2, 2, 2, and then finally we have position dumps. So there's 8, 9, 10, 11, sorry, this is 9 times n times speed. We have certain level here. It's not really relevant to us here, but let's just say n times. The final answer will be something like 12, 12, and 12, right? These two are fleet, these two are fleet, and this is a fleet. Altogether, your num fleets would be 3, right? Just to be clear, right? To separate this out like that, right? This will be the fleets. So essentially for this question, what we have to look at is car starting at 0, speed 4, to speed 2, become a fleet meeting each other at 4. The fleet moves to speed 2. Yeah, 1 car, 1 fleet, right? Straightforward. For the second example, the third one is 100, 0, 2, 4, 4, 2, 1, right? This one becomes 4, this one becomes 4, it meets, right? And then this one becomes 5. So 4 traveling at the speed of 2 and 5 traveling at the speed of 1 would meet again. So this would become speed 1. Yep, so there's altogether only 1 fleet. So when we look at this question, I think it's pretty tough to think of what we're supposed to do to solve this. Yeah. This is tough, this is tough. This 9, 5. Now what are we looking at? What are we looking at? We have 12. So let's think about what does it take. Okay, let's say assume that we have 2 cars, right? And when we look at the fact that when we have 2 cars, how do we know if they become a fleet, right? So the main thing is when you have 2 cars, the way to know whether or not target, time taken, right? Time taken for 1 car equals to target minus position divided by speed, right? For a car. And then when you see 2 cars, essentially target minus position divided by speed is the time taken for 1 car. And if you have 2 cars, standalone just 2 cars, the time taken, as long as the time taken, right, for them to reach the target is less than the time taken for another car, we know that, for example, if we have car A, right? If we have car A trailing car B, right? As long as the time taken for car A to reach the destination target is lower than the time taken for car B, this means that they will intersect and become a fleet, right? So essentially this is the key here. This formula here is very important, right? We have something like time taken A less than time taken B, right? So this is essentially formalizing this in terms of a formula that we can work with. And if A is lower than the time taken for car B, this means they will intersect and become a fleet. Yeah, and then looking at this, it's lower than the time taken for car B, means they will intersect and become a fleet. So how can we apply this on scale? Now the question is, how can we apply this to more than 2 cars, right? So essentially if we have car A, car B, and car C, right? Starting at arbitrary positions, we are looking at 3 cars traveling at different speeds, car A trailing car B and car B trailing car C. We want to know how we can apply these 2 cars, so we probably have to apply this formula to the first 2 cars first. Yeah, because the cars cannot intersect. The cars cannot overtake another car. We are more interested, right? Because cars cannot overtake one another, we should look at the car at the end first. See if any car before it will form a fleet with it, right? Is this true, or should we look at car A and car B first, or should we look at car B and car C first? So if we look at car A and car B, and we determine that car A and car A will catch up with car B, right? If we determine that car A will catch up with car B, these 2 form a fleet, then we take the slower speed of these 2 cars, which is likely the speed of car B, and compare it against car A, and see if we can combine this together, right? So car A and car B is like that, and we overlap car A and yeah, so I guess yep, something tells me we should do it from the back, but yeah, either way, because cars cannot overtake each other. So let's say we start from the car at the end, right? And then we check if it's car B and car C, and then we have make sure if car A and car, we check car B and car C, right? And if these two become a fleet, we want to check car A again, whether or not car A will catch up to these two cars. And then if they do, we'll add this on to the car. Since we know that this is a stack question, we probably can use a stack here. And in this case, the stack will probably be the car from the end, right? We append the stack here to the speed. We append a car to what we need here, and we have car A, car B, car C. Car A is supposed to come up to catch car B. And then this combined car will be a stack. And this combined car will be a stack. And we will append this. Check. Let's say we have a stack and we have a time taken stack, and we append this right away, right? Let's start with this example. Target 12, position 2, stack this, right? And then we have a time taken stack. So when we look at this entire array, we have 10 here and 2, right? So when we have 10, 2, we have a time taken stack. Time taken stack. We have a time taken stack here, and yeah, this is weird. Time time taken stack, position, speed. So okay, let's just follow this, right? The first one is I equals to 0. We have I equals to 0, and we have the first one here, which is time taken, right? Underscore 0. We're looking at this, so it's 12 minus 10 divided by 2, which essentially is 1, right? We are looking at 1. And then 20 divided by, so time taken will be 1. And then when we look at the next car here, right, we're looking at 8, 4, 1. We have 1 again. So since these two time taken to reach the goal is the same, we will combine them together. However, let's say, I think I got it, So let's say 10, 4, 8, 1, and here there was a car at 9, right? If there was a car at 9 traveling at a speed of 1, right? Then we have a problem, right? We have a problem here. What's the problem here is that if we have 10, 8, 9, and 2, 4, 1, this will not happen, right? The time taken here for them to reach the goal will not be 1 second. Why is that so? Right? In this case, time taken would not be 1 second, right? Because they will slow down due to car 9, right? Car at position 9. This guy would hit car 9, and then car 9 would hit, this car would also hit car 9. Essentially all of them would take 2 seconds, which is the speed of the lowest car. Essentially, this is the problem, right? We need to look forward and see what is the speed of the slowest car if we are approaching the problem from the front to the back. So we are looking at speed position 10, 2, and we realize that this takes 1 second, this takes 1 second, and then this one takes 3 seconds, right? This takes 3 seconds, and so we would have to slow down to catch up with 3 seconds. We can only travel as fast as the slowest car. We can only travel as fast as the slowest car in this case, right? So it's 3 seconds. And hold on. This is not right. We need to, in the first place, what we need to do is we need to sort the position of the array. This is, let's say we have this, right? And then, so we have 0. We have a position array and we need to sort this, right? So we need to have a position array here. And then this array needs to be, importantly, it needs to represent what are the positions of the cars, right? So 5, 8, 9, and 10, right? And then here there are corresponding speeds just to make sure we are correct. The one at 3 has car speed 3, 1. The one at 8 at speed 4, the one at speed 9 at 1, and then we have 2, right? So this is more important. We need to look at this question from this angle, right? We need to sort the position array. once we look at this is a little bit clearer when we look at this, right? We can see whether or not something can overlap with one. This is the first thing that is essential. We need to see if we can sort the array, right? We need to see if we 0 is 3, 5, 8, 9, 1, 3, 1, 4, 1, 2, right? And then whether or not something catches up. So essentially what I mentioned earlier here in terms of 10 plus 2 and 8 plus 4, it was coincidentally valid because 8, however, because they had ended up going to the same number. However, yeah, if this was if this was 1, and yeah, if this was 1, essentially they would still intersect, right? And go at the lower speed of 11, and then it would take one more unit of time to get to the point. So here we are looking at sorting the position array to have a better understanding of how the cars would overlap and intersect. So we're looking at this again, and then we see that 0 and 1, 3 and 3, 0 and 1, 3 and 3 would never intersect, right? Let's just say time taken. And then we have this, the target is 12, right? So 12, 3 plus 3, 4, position 3, right? 12 minus 3, again, let's remember this, time taken equals target position minus speed, right? Right, so 12 minus 0 divided by 1, 1. 12 minus 3, it's 9, 9 divided by 3 divided by 9 divided by 3 equals to 4, right? So 12 minus 5 equals to 7, 7 divided by 1 equals to 7, right? Again, 12, 4, 4, 1. 12 minus 9, 3 divided by 3, 1. Divided by 1, 3. 10, 12 minus 10, 2, 2 divided by 2, 1, right? So all these are the time taken for all the cars, right? All the cars taken, the time taken for all of them to get to their destination. So now looking at this entire array, what are we looking at now? We have a time taken array of 12, 4, 7, 1, 3. If car A follows car B and time taken A is less than time taken B, they become a fleet, right? So again, now we're looking at this. Do 12 and 4 become a fleet? No, right? When 12 and 4 do not become a fleet, we increment the number of fleets by 1, right? So essentially when we traverse through the time taken array, traverse through time taken array, right? Then for 12 and 4, they do not become a fleet. So you start off with initialize num fleets as 1, right? Then num fleets equals 2, right? Now we are looking at the fast one, the fast car, which is 4, right? 4 and 7, do they become a fleet? 4 and 7 do become a fleet, right? So for 4, 7, they become a fleet. So my num fleets, right, becomes -1 here. 12, 4, 7. So 12, 4, 7. And then 4 and 7 essentially becomes a fleet, but this 7 will be the slowest time it takes to get to the position, right? To get to the target. So now we're looking at 1. So now we look at 4, 7 compared with 1, right? Obviously 1 doesn't come out, so num fleets equals to 3. No combine, right? Num fleets becomes 3. And then now we have 7, 1, 3, 1. Combine 4, 7 with 1, no combination. Compare 1, right? No combine. Fleets are now right, and then now we're looking at 1. 1 definitely reaches the position first before this, right? So with 3 combine, right? Hold on. For 12 and 4, they do not become a fleet. Number of fleets plus 1, right? 4 and 7, they become a fleet. So this is still 2. We do not decrease the number of fleets, we just ignore it. 4, 7 with 1, they do not combine, so we increment the number of fleets by 1, right? Then now we compare 1 with 3, it becomes 3. Nothing changes, right? One comma 3, right? So it's 1 comma 3. The slowest speed being 3. This one, the slowest speed is 3. The slowest speed here is 3. We're comparing 1, 3 with 1. This does not combine. So altogether we have num fleets equals to 4. Huh? But this answer is wrong. Why is this answer wrong? Because now we have 3 other subfleets, right? We have 3 other subfleets here. 1, 3 with 3, no combine. So essentially this is not correct. This is incorrect, right? This is incorrect because there's something wrong with this. 3 with 1. Something seems to be wrong here. Okay, we have 4 instead of 3. We are looking at these 3 fleets here. 12, 7, and 3. Essentially, yeah, the logic for this question is incorrect because we are not able to traverse the array from the front to the back. I probably would have gotten it correct if I had traversed the array from the back to the front, right? So because because of the nature of the question, we let's just look at this, right? So if let's just remove this and try this from the back. Okay, so we're looking at time taken equals to 12, 4, 7, 1, 3, 1. Yes, and then we are looking from the back. So 1 and 3 do not become a fleet, right? We're looking at 1 and 3. This takes 3 seconds to catch up. This takes 1 second to catch up, right? Two, 8, and 4. How do I combine 10 and 2, 8, and 4? How do I combine 10 and 2, 8, and 4? Well, let's just say, okay, let's just say it's 2 fleets, right? Num fleets, and then we have the fleets. Num fleets here. You initialize it as 1. 3 does not catch up with this, so and then 1 and 3 equals to 2. Initially you start off with 1, right? 1, and then you come out here, you have 3 and you have 1, right? And then you come to the next one, you have 1. 1 will overlap with this, so 1 and 3 now fleets equals to 2. 1 and 3 combine to 1, right? And then you have yeah, I added this. Essentially, if we didn't have this, yep, I guess my answer here should be correct. Yeah, I'll take some time to review the solution for this in the interest of time, but yeah, that will be all for this question. I don't think I would be able to solve this under interview setting, but yeah, I'll study the question again. Thanks for watching.